This is the Smart Buildings Academy podcast with Phil Zito, episode 230. Hey folks, Phil Zito here, and welcome to episode 230 of the Smart Buildings Academy podcast. And in this episode, we are going to look at cybersecurity basics for building automation professionals. So everything we discuss can be found at podcast.smartbuildingsacademy.com/230. Once again, that's podcast.smartbuildingsacademy.com/230. And today's episode is brought to you by our Information Technology for BAS Professionals course. If you are looking for a resource to learn information technology, including cybersecurity, but also network design, database, troubleshooting, and much more, then I encourage you to check out that course. The link will be available at podcast.smartbuildingsacademy.com/230. Okay, so recently I've seen a lot of information coming across the wire, people talking about cybersecurity issues, people talking about what's happening in buildings. Obviously, because of the current state of the world, we are increasingly using remote connectivity to access our building automation systems. So does that mean that every building automation system needs to be locked down super tight? Or should we not lock them down at all? Or should it be something kind of in the middle? Well, it really depends. I think first off, in order for us to even address that question, we need to discuss what is cybersecurity, what's a reasonable level of cybersecurity, and then this concept called the CIA Triad, and then finally talking about what controls are in regards to cybersecurity. Once we've done all of that, then we can start to actually look at where we would protect a BAS and how we would go about protecting a BAS, whether we have a cybersecurity background or not. So what is cybersecurity? Cybersecurity, quite frankly, is the act of securing our information systems from both intentional as well as unintentional threats. People often forget that an aspect of cybersecurity is actually making sure that we have disaster recovery, that we have redundancy. Folks could argue that that's not cybersecurity from a purist perspective, that cybersecurity really should just be focused on external threats that are malicious in nature. But the reality is there's external threats to our building automation systems that aren't malicious in nature. If IT goes and takes down a server and relocates it, that could take down our building automation system. If they change IP addressing, that could take down our network. And while not exactly cybersecurity in the purest sense, it is a system availability issue that we need to be cognizant of, and we need to have plans in place on how to address it and policies on how to address it in order to ensure that our systems remain available, which will become an important word a little bit later in the podcast. So then what is a reasonable level of cybersecurity? What would be reasonable? Well, oftentimes when we look at cybersecurity outside of the building automation world, like the financial sector, the healthcare sector, et cetera, we look at the risk of the potential cybersecurity threat. So what is the likelihood of that threat occurring? What would be the financial impact of that threat occurring? And then that gives us a potential cost of impact. So it's basically like an actuary table where they look at the likelihood of someone in a profession dying or someone with the following habits dying, and then based on those habits and or profession, a risk level is associated with that person, and that affects the cost of insurance and cost of various things. The same is true with cybersecurity, but how do we do that from a building automation perspective, especially considering, if you believe that there are no cybersecurity threats to buildings and that no building automation systems have been hacked and nothing has been compromised, then I hate to tell you, but you're living in a fantasy world. The reality is, unlike with payment data, unlike with privacy data like healthcare data, when a building automation system is compromised, there is really no regulatory body or regulatory compliance that requires manufacturers or facility operators to report on that compromise. The same is true in industrial situations. Usually, the only time you find out about this is when it's either high profile and the hacker themselves brags about it. It was done by a white hack or a white hat hacker who, um, is not necessarily malicious. You've seen this in some of the Google stuff where a system was compromised and someone went and published it at a trade show. But there's a variety of things that are going on behind the scenes. And you can find out about them at like ICS Cert and US Cert that we're they're never really reported. They're never made aware to the general public. They don't rise to the level of, the Home Depot point of sales attack or things like the Stuxnet with SCADA. You just don't hear about these things. And so it gives the impression, and wrongfully so, that there are no attacks on systems. Now, on the flip side, is a cybersecurity attack on a building automation system really the end of the world? I mean, it depends. If someone goes and logs into your commercial office building, that's a 2-story office building with a rooftop unit and some VAV boxes, and they start changing set points, yeah, that's a nuisance. It requires time and cost to go fix, but it's not the end of the world. If someone goes and pressurizes all the stairwells and then causes some sort of issue with the building and people are trying to escape and they can't open the doors on the stairwells because stairwells are pressurized, that's like a whole nother level. If someone shuts down the chiller to a data center, that's a whole nother level, or shuts down the conditioning to a hospital, that is a bigger issue. So the level of cybersecurity response you need really should parallel to the criticality of your facility. And the reality is, certain facilities just aren't that critical. No one likes to hear that, but it is the truth. When we approach cybersecurity, we look at this concept called the CIA Triad, which stands for confidentiality, integrity, and availability. When we are talking about building automation data, we are primarily focused on integrity and availability as our biggest points of focus, and then confidentiality kind of comes in after the fact. The reality is that, BACnet, not exactly a secure protocol. HTTP, definitely not a secure protocol. And the reality is the data that we're sharing between systems, I mean, there are some instances in manufacturing plants and such where you don't want the environmental data exposed because that can qualify as a trade secret in the development of a product. But the reality is no one really cares what your space temp is in your office building. No one really cares what your chiller set point is in, your school. That's not really data that needs to be confidential. So at the end of the day, the C aspect of the triad and the controls associated with confidentiality aren't our primary focus. Our primary focus from a building automation perspective is integrity and availability. So integrity means that if I send a 72-degree set point to a controller, no one is interfering with that set point. They aren't interrupting that set point and causing it to become 80 degrees or 55 degrees. And then availability is quite simply the availability of that resource. Whether it's that network endpoint, whether it is that controller, whether it's that server resource. So when we think about our controls that we can implement in cybersecurity, we're primarily focused on integrity and availability controls. Now, that's not to dismiss talk about business continuity, which in my opinion would be availability. That's not to talk about having disaster recovery, which also would be availability. So in my professional opinion, everything can come back to the CIA Triad concept. Now, you hear me mention the term cybersecurity controls, and I'm a firm believer that in order for us to have intelligent conversations, we all need to speak the same language. So controls in the cybersecurity world are not to be confused with a hardware device. They may be a hardware device, like a firewall, a different like locks on a door for physical security, things like that. But at the same time, they may be software. They may be a administrative policy. Controls are just mechanisms to control the threat and to reasonably neutralize, or as they say, mitigate the threat. So we go and we look at the likelihood of a threat. We multiply that times the impact of the threat. That gives us a total cost of the threat. And then we implement a control that is equal to the cost of the threat. In most cases, some cases you'll implement a control that's more than the threat because the potential long-term impacts of the threat could be higher, stuff like that. So when we look at this cybersecurity and we look at BAS protection points, what do we have? Well, we really have three major protection points, and those are the network, the application, and the physical. So I'm going to start with network, then we'll move through application, then we'll move through physical. When we're talking about network, we have both the external and the internal network. So the internal building automation network, so here's how I feel about that. There's a lot of talk about managing cybersecurity on an internal network, and there's like, we want to make sure it's secure communication between devices. We want to make sure that there's MAC authentication of any device that gets hooked up to the network, et cetera, et cetera. My philosophy has always been to focus on the external network, to focus on the application settings, to focus on physical access controls, and to focus on administrative policies prior to focusing on internal networks. Because if someone compromises the building, so defense in depth basically is this layer model of, hey, first they have to get in the building, then they have to get into the space where the device is at, then they have to get access to the device, et cetera, et cetera. And the same thing with the network, right? First they have to access the external network, then they have to get into the internal, da, 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 da. Well, the point is that if they are in the internal network, then multiple security controls have failed. So if I'm looking at where my most likely entry points are, it's external. Now, that being said, there are people who will effectively argue that your most likely entry points are internal. There's this story of a security guard for a hospital who got let go, and he had left himself a way to access the building automation system, and he was changing set points remotely. But I would argue that that was a administrative policy issue, in that they did not go and understand what access points were available, what username and passwords were available, and they did not have a policy maybe tied to LDAP, which is an authentication use. Like if you've ever logged into your corporate server and it's had you use your corporate username and password, that's a Active Directory authentication. And that's what that stands for, by the way. So LDAP is a protocol for Active Directory. So basically they had no way of controlling that. And because of that, he was able to access things. So it wasn't really a issue with the internal network as much as it was an issue with policies. All right. That being said, some people really frown upon that kind of turtle approach, which is a hard shell with a very soft interior. Concept of like if you have a turtle and you break its shell, everything's soft inside. So, with that hardened external network, but a softened internal network, depending on the risk to your enterprise, that could be a bad approach. But for most of us, like if we think of the Pareto principle, and we think that the majority of our buildings are going to be, commercial office buildings, they're going to be kind of on the lower end. Everyone wants that, $5 million, $10 million controls project at a corporate campus or a hospital. But the reality is those buildings are the exception to the rule in a lot of cases. So when I look at network security, first thing I like to look at is, am I even required to access the network remotely? If I am, then rather than going and implementing all this fancy stuff, I just look for a router that has several things built into it. And those things I'm going to look for are going to be on the access control perspective and on the encryption perspective. And those are going to protect my integrity of data. and my availability of data. So typically, I will look for an appliance that has both a VPN aspect to it. So it's a VPN that can establish an endpoint. So basically, I already have to create a dedicated connection to the endpoint. So there's multiple devices that you can get, especially even if you're using a cable modem. There are ways that, or a DSL line, there are ways that you can get DSL modems and cable modems that have that built in, that have that access control list built in, that have a lightweight VPN built in. You can use basic encryption across that VPN. So there's multiple ways that you can secure the incoming network. It's actually not terribly difficult. Problem is that a fair bit of people in our industry do not have basic IT knowledge. And because they do not have basic IT knowledge, they don't understand how to go about setting these things up or that these things even exist. On the internal network itself, usually you want it air gapped, which means that the building automation network itself is separate from the business network. If that is not the case, you can do that logically instead of physically. That means you can set up VLANs, access control lists, and you could set up boundary firewalls and boundary intrusion detection, intrusion prevention systems. And what that means is that as you cross boundaries, like as you move from one VLAN to the next, like let's say for whatever reason, you want a VLAN that is separate from your business network, but you want the people on the business network to be able to go and access the building automation data. So you could, in theory, create a boundary that only allows HTTPS traffic from a specific host to a specific device. You could get that granular on your access control. And that can be set up in routers, that can be set up in some switches, that can be set up as an external appliance. And you can do this, or your customer's IT group can do this. In reality, what you should be doing, if you are doing an enterprise customer, you should be working with their IT group to talk about what you want to set up from a cybersecurity perspective. The really big hit, in my opinion, so yeah, external network access, you want to secure that, set up VPNs, set up basic secure tunnels, set up basic firewalls, that kind of stuff. Maybe even some packet management, packet logging, which can all be set up with a basic consumer grade router on your DSL or on your cable modem. I mean, most of those these days have that built in. Where I really see the things that folks are missing are more on the application and administrative side of cybersecurity. From an application perspective, I like to look at virtualizing my servers, so that way I'm handling redundancy. I have an image. If something fails, I can instantly fail back to a previous state that worked, or I can fail over to a different machine. So that deals with my availability and uptime. From an integrity perspective, I like to keep my systems patched. I like to be cognizant of potential risks to my systems. I like to go and ensure that I have minimal access for the software that is running on the machine. I don't use the server as a user interface device. I externally connect to the server, and I make sure I'm using settings like HTTPS TLS 1.2, not 1.0 or 1.1. I'm using different things like certificates to go and validate the identity of the server. And this is all going to help with my integrity. It's going to make sure there's no man-in-the-middle attacks where people basically put a device in between the communication and interrupt it. Don't worry if I feel like I'm starting to lose some of you all. I'm talking about concepts that are probably a little bit beyond some of you. That's totally fine. I just want you to be familiar with these terms. And at the end of this episode, I'll give you some brief recommendations. But I want you to at least hear this so that you can say to yourself, man, Phil's talking about this. I don't understand this. I'm going to go research it more because I want to be the best building automation professional I can be. I want to be cognizant of what he's talking about, and I really want to make sure that I understand what's going on. So that's from an application perspective. From a administrative perspective, password policies, patching policies, minimum user life cycles, or sorry, maximum user life cycles on accounts, account closure policies that are tied with employee dismissal. These are all basic things that should be implemented, and they're fairly easy to implement if you have the policies in place. And then finally, physical access. All of this stuff in the world, all of the cybersecurity policies in the world do absolutely nothing if someone can go and plug into a UDP port on a machine. Now, in some schools of thought, people will say, well, the reason you can't have IP controls, the reason you can't have XYZ system is because someone can access it and hack our network. I argue that the bigger issue is that they've accessed your building and they're in there working on something and no one's noticed. I've heard the old argument of we don't want to put IP controls in the ceiling because someone can get up in the ceiling and they can unplug the controller and plug their device in. Once again, the bigger issue is that someone is in your hallway with a ladder in the plenum working on something and no one's noticed it and no one has thought, that's weird. So having policies around physical access to systems, having physical access controls like locks and cameras and locks on your panels and not using the exact same key for every panel so that someone can just simply go buy a NEMA 1 enclosure off of Granger and now they've got the exact same key that's going to be used for every panel in your facility. So there's a variety of different things you can do in order to go and ensure that you have physical access control on your machines and on your systems. All right, so let's recap on all this. Our primary purpose on cybersecurity is to control the threat. We look at the likelihood of the threat, and this oftentimes, I'll be straight up with you, is just sticking your finger up in the air and feeling the wind and taking a guess. How likely is it that for a hospital, someone's going to try to compromise your network? There's not a lot of really good data out there, unfortunately, on the building side. There is a lot of good data on the business side. You can see about all these hospitals getting ransomwared, and you can see how that's happening. It's usually through email, stuff like that. So, those are definitely threats that exist. But the likelihood of someone compromising a building system, there's not a lot of good data around that. So you kind of got to take a guess. And then once you figure out, you got to figure out kind of what would the impact be. The way I back into the impact is I look at what would the cost of a system being down due to my cash flow in my facility. If a OR is down, that's a different cash flow impact than if a office building is just a little hot because the temperature is too high. So there's a variety of things. We look at the CIA Triad and we are primarily focused on integrity and availability. We reach integrity through our different encrypted endpoints, like our VPN from our external network, using certificates, using TLS 1.2, using HTTPS, things like that. All of that can be a wrapper to our traffic. Be cognizant, though, that there is some traffic, regardless, that is going to potentially be publicly exposed, like BACnet UDP or Modbus TCP. So just be cognizant that some of that traffic may be publicly exposed and could, in theory, be interrupted. There are ways to encrypt that traffic using end-to-end tunnels. You can go and do that. It is possible. For certain buildings, that makes a lot of sense. For other buildings, it makes no sense. And we want to make sure our applications that are patched, we want to keep stuff regularly up to date, not just the BAS software, but also the software on the computer. We want to virtualize our BAS servers as much as possible. That way we have failover and we have rollback capabilities. We want to establish administrative policies that are going to go and enforce password, maximum account life. We want to have policies for dismissal, and we want to have policies for setting up temporary access. And then finally, we want to ensure that we have physical access secured to our buildings as well. So this should give you a basic primer on cybersecurity, some ideas, some terminology, some more things that you can research. I encourage you, if you want to know more about information technology and cybersecurity, to check out our Information Technology for BAS Professionals course. And you can find that at podcast.smartbuildingsacademy.com/230. Thanks so much for listening to today's episode, and I look forward to talking to you again next week. Take care. Next week. Take care. Next week.